first one again so that it's on the video here. We'll scroll down to the second one. Again, first you find your reference angle. Did you get the right reference angle? And then, once you found your reference angle, tan is negative in quadrants 2 and 4. So this is a review of calculator questions from trigonometry. How to use your reference angle and your CAS rule to find your answers. Next, we'll do some without our calculator. For this first one, when you got cos by itself, did you get cos theta equals 4? And that's not possible because remember, cos is adjacent over hypotenuse. If we make this into a fraction, it'd be over 1, and then your hypotenuse would be 1, and your adjacent side would be 4. You can never have your hypotenuse less than a side. So this is how you know it's not possible. Now, what does chapter 7 do that's different is this. We solved questions, like if we go back, the first two questions you solved, this is chapter 6. Chapter 6 gives us a specific domain. Sometimes it was negative 2 pi to 2 pi. Sometimes it was 0 to pi. They give us a domain which we solved over. Usually it's 0 to 2 pi like we did here, which is once around your unit circle. What chapter 7 brings is that we will now change the domain. Instead of just being from 0 to 2 pi, we say it can be everything. So we take out our circle and we can go multiple times around. So the idea is, if you solve from 0 to 2 pi, usually you find two answers. One here, one here. If you went a second time around, you'd get another two answers. The third time around would hit two more coterminal angles. And so everything that's coterminal with your first answers will be answers as you keep on going. So what do? We solve this like normal. So I get tan by itself. Recognize that negative 1 over root 3 is the same as root 3 over 3. That's on our pi plate. That's part of our pi over 6 family. And so if I was solving between 0 and 2 pi, this is what I would get. And this is chapter 6. This is where chapter 6 would end, and you would just be like, I've got my two answers, I'm done. What does chapter 7 do? By saying the domain is everything, it actually just combines two things from chapter 6 you already know. You already know how to solve between 0 and 2 pi, and you already know how to write all the angles that are coterminal with any angle I give you. For example, let's take 5 pi over 6. 5 pi over 6 is right here on your unit circle. If you add 2 pi, you'd end in the same place, right? How do we write all of the angles coterminal with 5 pi over 6? We just went 5 pi over 6 plus 2 pi times k, where k was an integer. So if we did that, right, here's a little diagram of what's happening, we'll write our answer like this now. We'll take the answers that we got between 0 and 2 pi, and then we'll write everything that's coterminal with 5 pi over 6 and everything that's coterminal with 11 pi over 6. And I think in chapter 6, we often wrote 2 pi times k. The general form, they moved the k before the pi. I don't know what's the hierarchy of variables, numbers, and pi, but it seems to be, instead of writing 2 pi times k, we write 2k pi. It means exactly the same thing. So this is a way of writing all the coterminal things of all the angles. And we're going to start to notice that with, and I drew a diagram of both 5 power 6 and 11 power 6 here. This only works with tan, but can you see that tan in between these two answers is halfway around? So another way that we could have written this answer, and most of the time we're going to write it this way. Our strategy when we write it on the next page for the general solution will be find your answers between 0 and 2 pi, which we did, and then add 2k pi to write every single coterminal one for each of them, and you'll have your general solution. But with tangent, you could make it shorter because you could start at 5 power 6 and then just do jumps of pi. That would get you to 11 power 6. Another jump of pi would get you back. And this is equal to the other answer, just shorter. So you'll sometimes see that in textbooks for tan, or even on multiple choice questions on exams, because it's more elegant looking. But if you had a long answer question, you could write it either way. So, at the top of page 574, write out the steps for the general solution. And the two steps for the general solution are just two things you knew already from chapter 6. So it's a bit of a review of chapter 6. You already know how to solve between 0 and 2 pi. Yeah, so in the space at the top of page 574, write this down. So we're going to solve like normal from 0 to 2 pi. Then you already know how to write coterminal angles by adding 2 pi times k. So we're going to just take each answer that we have and add 2k pi, where k is an integer, to solve. Yes?
Isn't there more than one 273 to write it? Because 274 is kind of
I think it works either. If you want to write it on 273, it's fine. Okay, all right. So, we are, instead of doing example 1, so you can put an X through example 1 because we're not going to do it. We're going to do this question instead. Solve for theta, general solution. So we know it's a general solution when either they give us theta ER, or they say find the general solution, or technically, if they say nothing at all, it should be the general solution. We want to solve 7 sine theta plus 1 equals 0. So to start, we'd get sine theta by itself and get negative 1/7. Go to your calculator, do sine inverse of positive 1/7. So I hope you're getting good at that part for your reference angle, that your reference angle is always the sine inverse of the positive value. And once you have your reference angle, you can find it in quadrants 3 and quadrants 4. This is what chapter 6 looked like, solving for something between 0 and 2 pi. What does chapter 7 add? Well, now we just need to write all of the answers that are coterminal with it. So we just add plus 2k pi, where k is an integer. So what's happening is we're combining, solving between 0 and 2 pi, and writing coterminal angles together. All right, next example. Find the general solution for 5 cos theta plus 1 equals 0. I'd like you to try this one on your own. So first, solve between 0 and 2 pi. You're going to need your calculator. And then write the general solution. All right. Here's the answer. So you can check, did you get those two angles? Then you just go plus 2k pi to each one. Another one to try on your own. I'll put it up in a second. Here, yeah. All right, let's see if you did the quadratic formula part right. There's your quadratic formula. So for this equation, you don't have an x squared, we have a tan squared. So we would have tan theta equals negative b plus or minus b squared minus 4 times a times c over 2 times a. So this simplifies to be negative 3 plus or minus 28 plus 9, 37 over 2. I hope you can see that this is not on our pie plate. So we need to solve for the reference angle for both, and I'm going to split it up into 2 sections here. We are going to have one section where tan of theta is negative 3 plus the square root of 37 over 2, and one section where tan of theta is negative 3 minus the square root of 37 over 2. This is the general solution question because if we look to the original equation, nothing was set. It just says solve for theta. So if they don't give you any domain, you assume the domain is everything. How do we solve a general solution? We start by solving between 0 and 2 pi, just like we would in chapter 6. So I need to solve for tan. I've got tan by itself. I'll take out my calculator and I will find my reference angle. So first of all, I'm going to find out what negative 3 plus the square root of 37 over 2 is. Because it's going to be as a decimal, it's much easier to see that this is positive. I find my reference angle by doing tan inverse of this. I get a reference angle of 0.995. Then according to my cast rule, tangent is positive in quadrant 1 and in quadrant 3. So I get 0.995 and 4.137. The old provincial exam liked it if we always wrote our answers to 3 decimal places. In the second one, if I type this into my calculator, I get negative 4.541. I have to find my reference angle by doing tan inverse of the positive value. And this time I get a reference angle of 1.354. Tan is negative in quadrants 2 and quadrants 4. So I go pi minus my reference angle in quadrant 2. And 2 pi minus my reference angle in quadrant 4. This gives me 4 answers from 0 to 2 pi. For the general solution, then we write theta equals big squiggly bracket. We write all 4 of the ones we found. It doesn't matter the order. Some people like to write them numerically in the order that they appear. Like, there we go, they're all from smallest to biggest. Then we just go plus 2k pi plus 2k pi to each of them. Draw a straight line and then say, make sure we know that k is an integer. So, questions you can do for practice.